Assalamualaikum warahmatullahi wabarakatuh. Good day everyone. So in this video, I will continue to show you how to answer past year examination questions for MET 435 Calculus for Engineers for chapter 3. Okay, for the first one, we have July 2021, question 3. Determine the nature of the critical points of fxy equals to x squared y minus 2x squared minus y squared. So we have 4 steps that we need to do here. Okay, so let's see. So the first step is we need to find fx, okay, partial derivative for x, okay, based on the functions given here. So we will get d over dx of the function x squared y minus 2x squared minus y squared. Okay, so we need to differentiate this function with respect to x. So we will get, for this part, we get 2xy, okay, and then for this part we get this one, we get multiply by 2, 2 multiply by 2, we get negative 4, and then x minus 1, we get power of 1. So for this one, we don't have any variable x, so it will no longer be here. Alright, so and then we need to differentiate the same function with respect to y. Okay, so we have d over dy x squared y minus 2x squared minus y squared. So this one, differentiate this part. Okay, differentiate y, we only left with x squared. Okay, this part will be gone, and then this one we get negative 2y. Okay, and then second step, based on the partial derivative that we get, we will find our critical points. Okay, so find critical points. So how to find critical points? We will let these two partial derivatives to be equals to 0, and then we will solve simultaneously. Okay, so for the first part, we have our fx. Okay, so we have 2xy minus 4x from here to be equals to 0. So this is our first equations. And then this one is our second equation. X squared minus 2y equals to 0. This is our second equations. So now we will solve these two equations simultaneously. Alright. So continue here. So from equations 2 here, we can get new equations. So we have x squared equals to, so this one, okay, we bring it to the right side, so we get x squared equals to 2y, and then from here we will get our y equals to x squared over 2. So this is our third equations. And now our third equation, we substitute into the first equations here. Okay, so substitute, okay, 3 into equation 1. Okay, so we will have, okay, so we will have 2x. Okay, so this is our equation 1 right here. So now y we will replace with the equation 3. So 2xy now become x squared over 2. Okay, minus 4x equals to 0. So we will solve this one. Okay, so solve this one. Okay, right up here, so we get x minus 2, x plus 2 equals to 0. So the first x will be equals to 0. The one inside the bracket will be equals to 0. Therefore, we will get x equals to 2. Okay, and then here x plus 2 here will be equals to 0, and then we get our x equals to negative 2. So now we have our 3 value of x here. Okay, so next step we will find our value of y. So how? Okay, we will substitute all this value of y into our third equations here. Okay, because this one we already have our y as the subject. So when we substitute x here, we will directly get our value of y. Okay, so substitute x equals to 0, we will get when x equals to 0, we will get our y equals to 0. Okay, and then when x equals to 2, substitute into equations 2 also, equation 3, sorry, we will get y equals to 2, and then when we substitute x equals to negative 2, we will get our y equals to 2. Alright, so from here, please write back your critical point in bracket. Okay, so put some conclusions here, okay, to show the critical point that you got. So hence the critical points are, okay, so put this one in the bracket, the value of x first and then the value of y, 0 0. Second one we have 2 2. Third one we have n, we have negative 2 2. So we have 3 critical points. Okay, so for the third step, we will try to find the nature of the point. Okay, so before we can find the nature of the critical points, for the third step, we need to find our fxx, fyy, and also fxy. Means that from the first derivative that we get, that with respect to x, with respect to y, we need to again differentiate the same function. Okay, so for fxx, we will differentiate again our function that we already differentiate with respect to x. Okay, this one. So this one differentiate with respect to x again, we get 2y minus 4. And then for fyy, differentiate the partial derivative with respect to y, the functions x squared minus 2y. So differentiate with respect to y, we get negative 2. And for fxy, we will differentiate the functions, the partial derivative function that we get when we differentiate with respect to x. But now we will differentiate the same function with respect to y. Okay, so this one we will get to x. Okay, so just now we have our fxx equals to 2y minus 4, fyy equals to negative 2, and also fxy equals to x. Okay, so now we will use this formula to identify the nature of the critical point fxx, fyy minus fxy. Okay, so from here our fxx is 2y minus 4, our fyy is negative 2 minus with 2x. So we will substitute our critical point inside this formula, and then the answer we will put inside this table, okay, as the conclusion. Okay, so here this is our critical point. Okay, so we put our critical point here. So this is our critical points. Okay, and then here the value of our fxx, the value of our fyy. Okay, for each critical point, here is our value of d. So d, here is the formula for d, and then here is the conclusion. Okay, okay, for the first critical point we have 0 0, second one we have 2 2, third one we have negative 2 and 2. Okay, for fxx, okay, substitute inside this function here, fxx 2y minus 4, so substitute 0, so we get the value negative 4. And then for the second one, substitute 2 as our value of y inside the fxx function, we get 0, and the third one we also get 0. And then next one for fyy, so all of these we don't have any variable, inside of the function, so we will have negative 2, negative 2, negative 2. Then for D, we substitute inside this formula right here. So for the first one, when we substitute our value of x and y, our first critical point, we will get 8. Okay, second one we get negative 16, and then third one we get negative 16. Okay, so now for the conclusion part, so we only have one positive value, so this one will become our relative maximum. So I just put short form for this one, okay, relative maxima, and then this is negative value, our D less than negative, okay, so negative less than 0, okay, so good. So this will be our saddle point. Okay, so you can refer back to the conditions on how to determine a saddle point, relative maxima, relative minima. Okay, so please refer back to the notes. Okay, so this is our conclusion. So make sure you have your critical points, okay, and then the value for each one of these, fxx, fyy, D, and also conclusion. This is very important. Okay, if you have the table complete with all the informations, then you will get full marks. Okay, so July 2022, question 3. Use total differential to approximate the change in fxy natural log square root of 1 plus xy if the point varies from 0 to negative 0.09 to 0.02. So to approximate the change means that what we need to find if fxy plus with the change in f. So this is what we need to find. Okay, so in order to find this one, we need to find the df first. So df formula, we have our fx dx plus with fy dy. So we need to find this first. Okay, and then we will substitute back here, and then we get our answer. Alright, so first step. Okay, so we know the formula, so write down the formula first. Change in f equals to fx multiplied by change in x plus fy multiplied by change in y. Okay, so this is the formula. So second one, we find our dx. So dx will be equals to, okay, the point given here. Okay, so this point, second point, minus with the first point. So we have negative for the x first, negative 0.09. So the x here is negative 0.09. X here we have 0, so minus 0. We get negative 0.09 back. And then for change in y, we take the second point, 2.02 minus with the first point, which is 2. So we get 0.02. Okay, so in order for us to find the change in f, we need to find this partial derivative fx and fy. So the third one, we find our fx. So we need to differentiate the function given. Okay, this one, natural log square root of 1 plus xy. Okay, so we have here, I write down here, fxy equals to, okay, I bring the power down. Okay, this one is also equals to natural log 1 plus xy to the power of negative 1 over 2. And you can bring this power down, so to the front. So we have 1 over 2 natural log 1 plus xy. Okay, so this one will be differentiate with respect to x and also differentiate with respect to y. So differentiate this one with respect to x. Okay, so we get y over 2 1 plus xy. Okay, so I hope you already know on how to differentiate this one. Okay, so you have functions inside of another function. Okay, so we have natural log here. Inside of this natural log, we have another function here, 1 plus xy. Okay, alright, so we get this one, and then we differentiate the same function with respect to y. Okay, you get x over 2 1 plus xy. Alright, so you get this one. Okay, because when we differentiate log functions, we get 1 over, and then we need to differentiate the function inside here, and then you will get this. Alright. Okay, so next we will substitute into the formula, the first formula. So we have df equals to our fx y over 2 1 plus xy. Okay, and then change in x is negative 0.09 plus with our fy x over 2 1 plus xy multiplied by our change in y 0.02. Okay, so now we will substitute the value, the first value here 0 2 as our x and y. Okay, so the point is 0 2, substitute. Okay, this point we will substitute our x naught and y naught, substitute here, 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 here. So we continue on the next page. Okay, after substitute all the value into the change in f, therefore we will get 2 over 2 multiplied by 1, our change in x, negative 0.09, plus with 0 over 2 multiplied by 1, change in y, 0.02. Okay, so this one, calculate this one using the calculator, you get negative 0.09. Okay, so this is not the final step yet. The fifth step, what you need to do, we need to find the approximation, okay, of the total differential. So negative approximation of the total of the change in f. Okay, so we get negative 0.09, 2.02 equals to fxy plus with negative 0.09, our change in f. Okay, so this is df. Okay, so remember to use this last formula. Alright, so for this part we use the functions, the actual functions given in the questions, substitute our x naught y naught. Okay, so we have, remember, we have natural log of 1 plus xy, power of 1 over 2. Okay, so here plus minus we get negative 0.09. So substitute x naught y naught, we will get, remember the point given is the point given is 0 and 2. So we will get natural log of 1 plus with 0 multiplied by 2, we get 0 here, to the power of 1 over 2 minus with 0.09. So calculate this one, use the calculator, we get negative 0.09. This is our final answer. Okay, our third questions from July 2022. This is question 3b. So given that the volume of a container is V equals to pi r squared h plus 4 over 3 pi r cubed, where r is the radius and h is the length of the container. First question, construct a tree diagram to set up the formula for dv over dt. Label your diagram appropriately. So this is falls under topic chain rule. Okay, so first we need to construct. Okay, so because this is about volume, so volume will be at the top, and then inside the volume formula we have variable r and h. So r here, h here, so go of the branches. Okay, and then under r and h we will have another variable which is t. Okay, so this is rate, so we must have the time. Okay, so if we differentiate v with respect to r, we have the partial derivative of dv over dr, and then if we differentiate v with respect to h, we have dv over dh, partial derivative. Okay, for r we have dr over dt, differentiate r with respect to time, and then h we have dh over dt. Okay, to set up the formula for dv over dt, so we need to set up the formula. So dv over dt is changing the rate, changing for the volume. So we have dv dt equals to, okay, on the left hand side we have dv dr multiplied by our dr over dt. Okay, plus with, on the right hand side, we have, of the branch, we have dv dh multiplied by dh dt. So this is the formula to find the rate of change for the volume. Okay, so next we will continue to see the solution for number 2. Okay, for the second one, okay, for number 2, we need to find the rate at which volume is changing. So means that for this one, we will use the formula in number 1, which is dv over dt equals to our partial derivative of v with respect to r multiplied by dr over dt, okay, plus with our partial derivative of v differentiate with respect to h multiplied with dh over dt. So please be careful with this one, okay? This is not the symbol is different. So this one use del because this is partial derivative. Okay, this one is the d, the normal d. Okay, so this one is del, this one is the normal d. So please be careful with the formula. Please write down this formula before you do the step to solve. Okay, so write down this formula first for chain rule. Okay, so now we need to find dv over dr, dr dt, dv dh, dh dt. Okay, so in the formula, in the questions, the value for r is already given, which is 15 centimeter. This is from the questions. H we have 25 centimeter, and then there's another two value. Okay, rate for radius. Okay, the radius decreasing at rate 0.75 centimeter per second. So we have the word decreasing here, and this is the rate. So this is the value of dr over dt, and then decreasing here means that we have negative in front. Okay, another information given is the height increasing at the rate of 0.5 centimeter per second. Okay, so this one indicates the value of dh over dt. So this is increasing, so we only have positive 0.5, no negative. Okay, so now we have our dr over dt and also dh over dt. So what we need to find is dv over dr and also dv over dh. So how to find these two? We use the formula of the volume given, v equals to pi r squared. This is given from the questions, 4 over 3 pi r cubed. So we will find our dv over dr from here. So differentiate this one with respect to r, we get 2 pi r h plus 4 pi r squared. Okay, so from here, okay, we can substitute our value of r and also h. Okay, substitute, we get 2 pi our r 15, our h 25 plus 4 pi our r 15 squared. So we get the answer equals to 1650 pi. Okay, and then differentiate the same formula with respect to h. Okay, we get pi r squared. So pi r squared, substitute our value of r just now, which is 15 squared. We get 225 pi. Okay, so we already have all the informations. So now we can substitute inside the formula dv over dt. So dv over dt, change of volume, the rate of change of the volume equals to dv over dr. Our dv over dr is 1650 pi multiply with dr over dt, which is negative 0.75, plus with our dv over dh, 225 pi, multiply with our dh over dt, which is 0.5. So this one, calculate, we get negative 1125 pi. Don't forget the unit. This is volume, so centimeter cube per second. Okay, so this is the final answer. So make sure to write this formula before you start calculating. Okay, and then be careful when you differentiate. Sometimes you have some variable inside of the bracket, so make sure to expand everything before you differentiate. Okay. Alright, so we come to the last questions. June 2019, question 6. If fxy equals to x plus y exponent xy, show that d squared f over dx squared plus d squared f over dy squared is equals to x squared plus y squared plus 2 fxy. So this is a proving questions. Alright. So how to solve this one? So given the function here, we have function of fxy equals to x plus y exponent xy. Okay, we need to show that d squared f over dx squared plus d squared f over dy squared, okay, it is equals to x squared plus y squared plus 2 fxy. So for proving question like this means that we need to do this one, okay, by using the function given in the questions, and then the final answer must be equals to the one on the right hand side here. So we need to verify that. Okay, so what we need to do first is our first step, because we need to have second order of derivative here, d squared f over dx squared and also d squared f over dy squared. We need to find the first derivative first. First derivative. So d squared, sorry. So we have df over dx first. So find this one. Okay, look at the functions here. So here we see one function x plus y and also exponent xy. So here we need to apply product rule. So apply product rule. So this is our u, this is our v. So apply product rule, we have xy plus y squared. Okay, and then we have exponent xy plus with exponent xy. So I hope you know how to apply product rule. Okay, this is just I already simplify this one. Okay, before you get this form, okay, you need to expand first. Okay, do one by one. This is u, this is v, and another one, this one is also u and v here. So I have two product rule that you need to apply here. Okay, make sure you get this form. Alright, and then you need to differentiate f with respect to dy. Okay, this one also product rule. You will get x squared plus xy exponent xy plus exponent xy. So you get this. Okay, and then you need to differentiate again, because here we have order 2. Okay, so we have order 2, so means that we need to differentiate this partial derivative again. Okay, so we differentiate again for step 2. We get d squared f over dx squared. Differentiate the function, the first partial derivative. Okay, don't differentiate the original function again. You will get the same answer like step 1 just now. You take the one that you get in step 1, differentiate again. So you will get y exponent xy plus xy plus y squared. Okay, y exponent xy plus y exponent xy. So you need to be very careful with this one, because the function will be long as you differentiate, because this one apply product rule, so be careful. Okay, and then we simplify, we get xy squared plus y cubed exponent xy plus 2y exponent xy. Okay, and then another one you need to differentiate also with respect to y again. Okay, second order. So we get x exponent xy plus x squared plus xy x exponent xy plus x exponent xy. So simplify, you get x cubed plus x squared y exponent xy plus 2x exponent xy. Okay, so be careful when you simplify. Sometimes you can factor out, okay, like this one, we factor out the exponent xy, right? Okay, so after that we will combine. Okay, third step, remember just now we tried to get d squared f over dx squared plus d squared f over dy squared. So we will combine these two functions that we already differentiate 2 times, and then try to get the same form as the one given in the questions, because we want to do proving, so we must get the exact form as the one given in the questions. Okay, so write down. Okay, write everything. First, xy squared plus y cubed exponent xy plus with 2y exponent xy plus with x cubed plus x squared y exponent xy. Okay, another one, we have another terms 2x exponent xy. So try to simplify and get the same form as the one given in the questions. Okay, you will get you can factor out exy, you get y squared x plus y plus 2x plus y plus x squared x plus y. Okay, so you see x plus y here, x plus y here, x plus y here, so we can factor that out. So we have x plus y exponent xy y squared plus x squared plus 2. Okay, so this one is also equals to fxy. Okay, x squared plus y squared plus 2. Okay, so you get the exact same equation given as the one given in the questions. And then don't forget to put something like proven, okay, to show that you already proved and verified. Okay, we come to the end of the video for chapter 3. So thank you and all the best for your final examination.